Hi, I'm Skumud and this is lecture 13 for probability and statistics for digital analytics. Today we are going to learn about chi-square tests and non-parametric methods. So let's go over it. So first we have the topics that you can see up there. Oh, my mouse is invisible. So first we are going to discuss what is the non-parametric method. So seriously, is it there? Yeah. So what we have done so far is that we are discussing how to deal with the particular population parameters. So when we talk about parameters, you should imagine this 2x3 tables where we have the sample on top, and the other column is for population. Right, so the goal of what we have done so far is we are trying to use the parameters or numbers that we got from the sample to estimate what the actual population parameters are. And we have three parameters that are easy to deal with. First we have the mean, the average. Next we have the proportion or the ratio. And then we have the standard deviation. We just mentioned that, okay, there is a formula for that, but we haven't done any work on it. Just so you know, that the three main parameters are these three. And we use the mean, which we denote as x bar, and we use that to estimate the actual population, which is mu, the Greek letter. For proportion, that doesn't look like we use pH. And so has some fancy notation, and we use it to estimate the population proportion P. I'm not sure if there is no Greek letter for why is that, but anyway, for standard deviation we use S to estimate the sigma. And so we have two sets of writing notations to distinguish between the sample and population. Today, because these are parameters, we use the parametric methods. So today you can guess what we are going to do. No, we are going to use the non-parametric methods. That means we are not going to use these 3 or 6 parameters. So we can use something different, but nevertheless we still use the same process of hypothesis testing, and we still use maybe the new or the usual distribution. Compute the p-value to make guess. So yeah, in this lecture we are going to use we are going to learn the procedures that first do not require strict assumptions. By strict, let me zoom in a little bit. Yeah, by strict it means we have to assume that it forms a normal distribution. We have to assume that the number of samples is large enough. Yeah, at least 30 or 35, depending on what college you are from. And maybe we have to assume something else, like we have to assume that we know the standard deviation in advance, which doesn't make sense usually, but these are necessary assumptions. Today we don't need any of those. Then yeah, the second one, you usually do not deal with the 3 parameters that I just told you. Then we use less information from the data, which you will see in a moment, that we can use just a single table of counts of several numbers to perform this testing. But since we don't use that much data, we only use a few, we have no assumption at all, then it is kind of intuitive that they are less powerful. Right, so given just this set of data, you can conclude something meaningful, but it's not as meaningful as what we have done with the normal distribution. That has a nice curve, that has assumptions, that has theorem or whatever those things are. And so today yeah, let's take a look at some definition. So just skim it a little bit. This is pretty much the same as what I said before, but this one has a formal definition. So a non-parametric method is one that satisfies at least one of the following criteria. at least one, usually 3 or 2. And so first, it deals with normative data. And so this is the same distinction that we have had before about the discrete and continuous. It is sorry, it's out of the screen. Discrete means we have discrete numbers. We count how many of how many ways, how many combinations. But for continuous, we measure. We measure height, we measure breadth, we measure length, we measure time. All those numbers that have decimals. But now we are just dealing with the counts. How many of them are there? So it's easier to do the survey and of course to do the math later. Next, it doesn't deal with specific population parameters. Again, not those trees. And then this doesn't require assumptions about specific population distributions. Usually it's about a normal distribution. It was so powerful that we can use it almost everywhere. But not here because we are counting things. So that's it for the quick definition. So let's see how we can deal with the non-parametric methods next.